Hello. Hello. Good afternoon. Hello. Good afternoon. Hello. Good afternoon, all of you. Is it audible? Are able to see screen? Okay. So today we'll see the collision-free techniques. So in continuation with hash tables, there is a concept collision-free techniques. It is a way of handling collisions. So when you are inserting data in the tables, sometimes if the index is the same, then it is called as collision. Then this will be in this if the elements are to be inserted in the same location more than one, especially in our hash tables. So these collision free techniques will be useful. Is it audible, all of you? Is it audible, all of you? Good. Okay. You are able to see a screen also. Okay. So in this collision free techniques, there are two categories are there, two classes. One is the open hashing and second one is closed hashing. Op- Open hashing Okay. So in between some disturbance is there. So now cleared. I think everybody is able to hear and visible the screen. So these collision free techniques, two classes, two categories are there, open hashing and second one is the closed hashing. Is it okay, all of you? Are you able to hear? Just please give me one information, one message. Screen and audio. Okay. Because somebody disturbed, so that's why I stopped. So thank you. So in this open hashing, also known as separate chaining, I think this already saw discussed. So now we'll see closed hashing, also known as open addressing. And this closed hashing and open hashing, we can see the difference. You can see the difference like this. Whether the collision after occurring the collision, whether you are storing the data this outside the table or within the table. Within the table means in the same table. Okay, okay, okay. The main difference of this open and closing hashing is now how is it? Is it okay? Voice audible? Okay, okay. Thank you. So main difference, if you see, before going to that, we'll see introduction. We'll understand first what is exactly. We will understand what is actually this hash table. This is a simplest kind of hash table like our array records. Generally, we will declare int array of 100 or 700 or 1000. Then it will create an array of records. Here I have taken 0 to 700 array of record which contains 701 records. This is a simple kind of hash table array of records, and in this each record has a special field. That means we will store the records in the 0 to 700 array, and each record has a special field. Just see the number 506643548. This is what called a key. In this example, the key is a long integer field called number. It may be a Aadhaar card number, or it may be a employee ID, or it may be a student ID, student hall ticket number, it may be a vehicle registration number. So whatever data you are going to store the information, so that will be the key. Now we'll see the next. If you see this, when you are using this hash table, it is in the usage. Some slots will be filled, some are empty. Like this, out of 0 to 700, some one is filled, second one is filled, fourth one is filled, or 0, 1, 2, 3, 4, all we will call it as a hash index. 0, 1, 2, 3, 4, this is the record of array containing 701 records, and 0, 1, 2, all we will call it as a hash index. And the where the data, some slots are contained valid records, some are empty. So now we'll insert the data. So when you are inserting, what will happen, we'll see. So how will you insert the data? So for inserting a new data, for example, this person you are going to insert, having a number 58062565. The key must be somehow we have to convert this key into index. So where to? We have to keep this one. Index is 0, 1, 2, 3, 4 up to 700. There are 701 records are there. Some are empty, some are filled with valid records. Now we are going to insert one more valid record having a key. Now we are going to convert this key into the index, array index. That index is called in this, I already told you, hash index or hash value of the valid key or valid record. That record is identified by this key value. So for example, student information is identified by a unique number, student hall ticket number. A vehicle data is identified by its unique number, registration number. In the same way, a person information throughout the India using the Aadhaar card, that is a valid key. So here you have to convert first this key, that value, the valid record value, identification value, into the hash value. How will you conduct? By using a hash function. By using a hash function. Hash function is a function by which you will convert this key into the valid index, hash index, to insert the data into the record. So this number not one. There are so many varieties of functions, hash functions are there. In that, division method is one, multiplication method is one, middle square method is one. Like that, if you want, you can create your own method also, your own function also. So here we are using this hash function, standard hash function. We'll convert this key value into the hash value, hash index, by using a formula number mod 702. The number is 58062565 mod 701. This will be 3. So the index 0, 1, 2, 3. So 3 place is empty. So we'll insert this value in that record. This record will insert in the particular hash index. So next we'll see. So here our hash function is what? Number mod 701. What is 701? The size of the record. 701 is the size of the record. What is the number? The number is the key of the particular valid record. So we are storing that record in the array, record of arrays between the 0 and 700. So there are 0 to 700 means 701 records are there. So that is the number we will use for calculating the index. So here we have another record. We have another record 701466868. We will calculate the hash index by 701466868 mod 701. Then we will get the hash value 2. Hash value 9 mod 2. So what is the remainder of 9 mod 2? 1 is the remainder. That is what called the hash value. So if you divide this one with 101, you will get a remainder. That remainder is called the hash value or hash index. So now we got for this valid record having a number, key number 70146688 mod 701 will get 2. But if you are going to insert the 2 already occupied, it is not empty. This is not empty. So this is what called collision. Now we got a collision which is called as when a collision occurs. So this is what called collision. So when collision occurs, so we require a collision free technique to insert this value in the record, to insert this valid record in the particular record. So we have seen closed hashing. In this closed hashing, I have given a definition data in the same record. In the inside the record only, wherever the slots are available, we'll keep. But in the open hashing, that is separate chaining, it is different. We will store in the outside. That is a combination of array and linked list. I think we have seen that. So here, because this number 70146688 key number we converted into the hash index by using the function 70146688 mod 701. Why 701? There are 701 records are there. That is the size of this array. So then here we will see, we will move forward, and wherever the empty space is there, empty slot is there, we will insert that value. Here if you see, we got 2 here, 2 is filled. Then we will follow a formula h plus 1. What is h? That is a hash index. Hash index plus 1. So then h plus 1 means 2 plus 1, 3. It is also filled. Again h plus 2. Then 2 plus 2, 4. This is also filled. Again h plus 3. That means for hash index value, whichever you got, if it is already filled, collision occurs. In such cases, we will add for hash index value h plus 1. If it is empty, we will 2. H plus 3, h plus 4. Here h is hash index. So in program, we can use it hash index 2, we got 2. Or otherwise key plus 1. Key plus 1 mod 701. Key plus 2 mod 701. What is key? 70146686. We'll add 1 for this key, which is nothing but h plus 1. Which is nothing but hash index plus 1. If you add 2 for this key, which is nothing but h plus 2. So h plus 3. So when you see here in this scenario, h plus 1 means 3. H is 2. We got hash index value 2 for this key. H plus 1 is 3. Then h plus 1, 2 plus 2, 4. This is also not empty. Then h plus 3, 2 plus 3, 5. This is empty. Now we'll insert this value in the file. This is what called linear probing. This is what called linear probing. Here you are using the h plus 1 or h of x plus 1. So we are using, and we are finding, and we are moving forward until we get a empty slot or empty spot, and then we are inserting. This is what one of the collision free hashing technique. Linear probing. There are 3 categories are there under this closed hashing. The collision free techniques. We will store the data within the record only. Slot will store in that. If you see, hash table store a collection of records with the keys. What is hash table? So finally we'll summarize whatever you have seen so far. Hash table stores a collection of records with keys. So by using this key, we can get the data of the records. This key is a unique key. We'll, con- we'll convert this key into the hash index, and we'll store this key in the corresponding hash index slot. The location of record depends on the hash value of the records key. This is what I just now I told. So where to store the location of the record? It depends on the hash value of the record key. That record key will convert into the hash value. Based on that, we'll store that record in the particular corresponding location. In case already that hash index value already filled, then collision occurs. When collision occurs, the next available location is used. So in this scenario, searching for a particular key generally quick. Generally quick, even for item deletion also will be click. We'll see this program also. So now next, we'll see just see types of hash functions. So h of x is equal to the key mod the particular size of the record. That is a division method. That is what called division method or mod method. This hash function you can create by multiplication also, by multiplying with a constant. By multiplying with a constant. Based on the key value, you can use either a division method, or a division method is otherwise called as mod method, or multiplication method. And another one is middle square method. Middle square method. So in this, we'll follow this scenario. For example, just see here. For example, the key x is 7234 and 7234. It is a key. We'll calculate x square. We'll calculate x square. That means square of 7234. That value will be 523,30756. We will get this value. In this, we will find the middle value. So we will underline 3 on the left side and 3 on the right side. Middle 30 will be there, 30. That 30 is we will call it as a hash index. That 30 we will call it as a hash index. Or otherwise, we will call it as a hash function 30. And further you can do 30 mod the size of the record also. So this is what called middle squaring method. So these are the three methods, hash function methods. Because I am covering JNTU syllabus questions and you are finishing school for interview purpose. So here these three are the hash functions. The frequently mod method will be probing. The rank method are there in this closed hashing. In this closed hashing. Please don't confuse open hashing, closed hashing. The closed hashing also known as open addressing. So you please remember closed hashing. So in this, the records will be stored within the records only, within the array only. Wherever the collision occurs, wherever the slots available, will store that value within the array, the records. And this quadratic probing, linear probing. Linear probing means If a collision occurs, we will see H plus 1, H plus 2, H plus 3 till empty space or empty spot get, we will do that. And initially we calculated hash function. Because of the collision, we are recalculating, rehashing, we are recalculating the hash function. H plus 1, H plus 2, H plus 3. This is what called rehash. If collision occurs, we will go for rehash. And in the quadratic probing, in the linear probing, we will use h of x. In the quadratic probing, we will use h of x comma I. H of x comma I. And h of x comma I is equal to, there is a formula, h of x plus c1I plus c2I square. Mod whatever the size of the record. Just see here in example set, we have a set 98, 56, 23, 50, 45. There are 12 numbers are there. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers are there. We are keeping 8 records into slot k is equal to 12. The hash index, hash table size is 12. And we are going to insert the records, 8 records. The hash table size k is equal to 12. So that k we will use as a mod k, where k is equal to size of the hash table. So for quadratic probing, we will use this formula. But there is no compulsory to use this formula only in case of quadratic probing. You can use 3-4 varieties. That we will see later. Like in the linear method or a middle square method, but frequently used one is division method. That is mod method. So we will by using this division method only. Is it okay, all of you? Shall I move or shall I repeat? Just give. Shall we go? Or shall I repeat once? Hello? Hello? Okay, thank you. So this is all the introduction of the hash table. I think you all covered. For example, if the record, the vehicle registration numbers are there. Just see this one. Vehicle registration numbers are there. AP12H3792. Second record MH 14B59984. Third one UP32CD 1008. So vehicle types two-wheeler and four-wheeler. And this hash value will be calculated in this scenario like this. The A to Z will be given a numbers 1 to 26. So the A value is equal to 1 plus P value is equal to 16. 1 plus 16 in case of AP12H3792. The hash value will be calculated 1 plus 16 plus 1 plus 2 plus H is the serial number 8 plus 3 plus 7 plus 9 plus 2. So totally the value will be 49. And this we are going to insert in a hash table size 15. So there are 0 to 14 are there, 15 is the key, that is the hash table value. So then we will calculate 49 mod 15. So then the remainder is equal to 14. So this will be stored in the bucket number 4. This will be, that is hash index 4. That we can call it as a bucket also. So hash 0, hash index size is 0, 1, 2, that is the array index. If the hash table is array of records, then hash index, we, we can call it as a bucket also. It will be stored in the bucket 4. So like that we will calculate for all the vehicle registration numbers, we will calculate like this hash value and we will insert in the corresponding hash table as per the bucket index or hash index. This collision, somewhere you will call it as a overflow also in case of buckets. So in this closed hashing, we have linear probing and quadratic probing, random probing also there. So in the linear probing, we'll select the next by using the function next slot by using a function h of x. In case of quadratic, we'll use as h of x comma I. So like that, we'll open hashing already sir explained. So that's why that I am not touching. So this is the open hashing. It's a combination of array and linked list. So in examination, in JNTU examination or even if you go interview, they will ask you sometimes like this also. They will give you the numbers, the keys 6, 12, 34, 29, 28, 11, 23, 7, 0, 33, 30, 45. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 records are there. These 12 records, you have to go to insert in the hash table having the size 17. There are 17 buckets are there. The hash table contains 17 buckets. It is separate chaining. In examination, they may ask you, he will give numbers like this and he will ask you to insert and showing the diagrammatically like this. Then you have to use, this is separate chaining. Open hashing example. I think you have done program. Sir explained already program. Just this is for your kind information. In examination, if they given like this, you have to calculate key percentage 17. 17 is the size of the hash table. So like that, for each and every key, you have to calculate and you have to put 0, 1, 2, 3. So I think this is already explained by sir. Shall I explain this one or sir explained? Just put a message, put it in the chat box. If you want, I will explain this one. If already explained, we will proceed. This is in JNTU examination point of view or in interview point of view. They will say these many records are there. How will you insert in a hash index? Having a hash index buckets 17 are there. So then you have to explain like this. Okay, fine. I will see closed hashing, linear probing. This is the example for the linear probing. Linear probing, we are using division method. And in this hash table is there having 17 buckets. Now, the hash index values are 0 to 16. The first space hash of 0. Hash index is 0. Second one is 1, 2, 3. Like the 16, 17 buckets are there. The values you are going to in 28, 11, 23, 7, 0, 33, 30, 45. Initially, the table is like this. For in the programming, for identification purpose, we will initialize all the records in the hash table will initialize with -1. So if the table is, if each and every bucket has with -1, we will understand that it is empty. If it is not -1, if some number is there, it is filled with some record. Then we will rehash and we will find the next slot. So we will do in the program like that. So here the key values are this one 6, 12, 34. These are the key values of the particular records. The first one is 6. So we'll say 6 mod. We'll say 6 mod 17. 6 mod 17. So remainder is equal to 6. So that we'll store the 6 key in the hash index 6. Just see 1, 2, 3, 4, 5, 6. 1, 0, 1, 2, 3, 4, 5, 6. We'll keep in the graph. Second one is 12. 12 mod 17. The remainder is equal to 12. So we'll put in the 12 index here. We'll put in the 12 index. Next one is 34. 34 mod 17. So the remainder is equal to 0. We will put in the 0 index. Hash value is equal to 0. So we will put the record here. Next one is 29. 29 mod 17. 12. So in the 12, hash value is equal to 12. But in the 12 already filled. So then we will see 12 plus 1. 13 also not filled. So we will put in the 29 there. Because it is empty. Next 28. 20. 11. 28 mod 17. 11. So 11 means 11 hash value, hash index, it is empty. So we'll put 28 here. Next is 11. 11 mod 17. So the remainder is 11. So hash index, hash value is equal to 11. But in the 11, 28 is record is there filled. So then h plus 1. So 12 filled. H plus 2, 29 filled. H plus 3 empty. So we'll put 11 here. We will insert this record in the 11. So 13, 14 hash index value place is empty. We will put 11 there. Next 23. So 23 mod 17. So 6. Remainder is equal to 6. So 23 minus 17. So 6. Remainder is equal to 6. So we'll hash index is equal to 6. But in the hash index 6, already record is there. Filled. Record is filled. So then we will see h plus 1. So 7th index value record is empty, spot is empty. We will put 23 there. So next is 7. 7 mod 17. So record 7 mod 17. So remainder is equal to 7. So hash index value is equal to 7. But in the hash index value 7, the hash table if you see, so it is filled. So then h plus 1. So 8 index it is empty. We will put 7 here. So next 0. 0 mod 17. 0 mod 17 is 0. So then hash index is equal to 0. We will go to the 0. But here it is filled with 34. So then we will go h plus 1. So second h of 1, hash index 1. It is empty. We will insert 0 there. Key value. Next 33. 33 mod 17. That is equal to 33, 17. 117. Next, how much? 33 mod 17, how much? Hello, 33 mod 17. How much? Give me message, somebody. 33 mod 17. 16. Very nice. So, it will go to the 12, 13, 14, 15, 16. It will go. So, 16 is empty. So, we'll put 33 there. Next, 30. 30 mod 17. 13. So, it will go to the 13. But it is filled. H plus 1 filled. H plus 2 filled. H plus 3 filled. So h plus 15 from here, this one is empty. So we'll put in the hash index value 15. So now 45. 45 mod 17. How much? 45 mod 17. 11. So we'll see 11. So 11 place is empty or full? Full. 11 place is full. H plus 1 filled. H plus 2 filled. H plus 3 filled. H plus 4 filled. H plus 5 filled. Here this value will add to the H. So that's why the next value comes to the here 0. And then H plus after 16, H plus 17, so H plus 18, so that you will get hash index value 0. How it will be? So H is nothing but we have to add the key value. Okay, that means 45 plus 1 mod 17, 12. 40 plus 2, 45 plus 3, 4, 5, 6, 7. So like that you have to add 1, 2, 3, 4, 5 to 45 and then you have to calculate mod 17. So then we will get the hash index value 2 which is empty. So there we will put the 45. So there are 17 records are there. In that we have kept 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 records we inserted. So the remaining are empty. So remaining will be identified with -1. So in the program for identification purpose, we will initialize first all with -1. So that we will see in the program how we will do. So this is theoretically. So first what we want hash table size and the key values. The key values you can take one by one from the user or otherwise you can take like these 10 values and you can store in one array. And by traversing this array, we will take each and every key and we will find the hash function. We will find the hash index by using the hash function. And that hash index we will put in the hash table and we will find whether it is empty or not. If it is empty, we will insert the record in the hash table. If not empty, we will rehash. Again, we will recalculate by adding 1, 2, 3 till we get the empty space. This is the concept of the linear probing. It is a form of open addressing. Probing, quadratic probing theoretically we will see like this, h of x plus I square. Earlier I have shown h of x plus c1 I square. So you can use for quadratic probing hash function in 3-4 methods. You can use like this h of x plus I square where I value will be 0, 1, 2, 3, 4 or otherwise you can calculate this by h of x plus c1I plus c2I square where c1 and c2 are the constants and I is 0, 1, 2, 3. So we will take I value as a 0, c1, c2 constant values they will give. We will calculate every time hash function. We will calculate a hash function. If the slot is available, we will insert. Otherwise, we will calculate, we will rehash. Again, we will calculate the hash index, which is called as rehashing. So this will be done in the quadratic probing. You will see in the program also. The another one is random probing. In this random probing, we will use h of x is equal to h dash x plus s of I mod b, where b is the size of the particular bucket or size of the hash table, and this s of I is a table size minus b minus 1. So another I value will take b minus 1, b minus 2, b minus 3. So randomly the s of I randomly will take I value and then we'll calculate. So this is the random probing. In syllabus we have a linear probing and quadratic probing, 3 concepts only. But when you go for interview, they may ask you either theory or programming. So now we'll see the program to implement hashing using linear probing. So first program we will see linear probing. The linear probing, the hash table size is 10. So we'll ask the user will take the hash table size from the user. In our case, we are taking one test case. We are taking a 10 is a hash table size. So our hash table size is equal to 10. Enter the number of elements 8. So these 8 elements you can take from user one by one, and we will calculate the hash index, and then we will insert. If not slot is available, we will rehash, and then we will search for next hash index value, slot is empty or not. Like that we will rehash until we will get the slot. The otherwise we will take all the values, all these numbers to be inserted, and we will keep it in one array, and then we will read the array, and then we will calculate for each and every element hash index, and then we will insert in the hash table. So these all are the hash numbers 23, 43, 56, 6, 78, 89, 19, 23. For example, user entered these 8 numbers. So the size of the hash table is 10. So every time we will calculate 23 mod 10, 43 mod 10, 56 mod 10. Like that we will traverse the numbers by using for loop, and inside the for loop we will calculate the hash index by using a hash function, the number mod hash table size. And after taking the hash table, we will take 2 arrays here. One is the hash table array, and second one is the another array for storing these numbers. Hash table by hash table of 10 we will take, and in the int hash of 10 we will initialize all values with -1, so that whenever you insert, we'll check whether it is -1 or not. If it is -1, we'll insert. If it is not -1, we'll rehash, and we'll get one more hash index, and we'll check whether it is empty or not. If not, again you will rehash. So until you get an empty spot. So this is the test case. Now we'll see the program. Hash include stdio.h. This all you all know preprocessor symbol. So we are giving information to the compiler that we are going to use the methods in the stdio.h, conio.h. And globally are taking hash table size, int t size. T size is the hash table size. And here 2 methods are there. One is calculating the hash index, and another one is rehashing. First one, there are 2 methods are there. One is hashing. Hashing is common, and linear probing will come when if empty space is not available, then we will rehash. Rehash L, that is linear probing. So for hashing, whenever you read key from the user, that key will pass through the hash t function. This hash t function takes that and calculate the hash index. How this hash index will be calculated? Take a I integer for storing the hash index. I is equal to key mod t size. Key is the number, the valid record number entered by the user, mod the size of the hash table. Size of the hash table in which we are going to insert the tab data records. So I is equal to key mod t size. So I will be calculated, we will get a hash index. This function will return that I. Then we will take that I, and then we will find whether in the hash table whether it is empty or not. And another rehash function is there, rehash L, int rehash L. Earlier one is int hash t int key. It is a return type, integer return type. The name of the function is hash t. Argument you are passing is key, the valid record key entered by the user. That is integer key. That key will go inside the function, and inside the function we are going to calculate hash index. So we are storing that hash index, that hash table index we are storing in the I. So I is equal to key mod t size. So it will return this hash index. The another linear probing function. If it is not empty, then you have to search for next one. So again you have to rehash. The rehashing will be done like this. Int rehash L int k. If the return type is integer, the name of the function is rehash L int k. Again that key will pass, and we will calculate the hash index like this, key plus 1 mod t size. That is h plus 1. That is nothing but h plus 1. If you key plus 1 means, if you calculate key plus 1 mod t size, we will get, if the earlier one hash index is h, we will get h plus 1. If key plus 2, h plus 2. If key plus 3, h plus 2. Like that, the I will be calculated and it returns the I value. This is the rehashed index. These two are the functions we are going to call from the main. So now we will see in the main function. We will see in the main function, declare void main, declare key for taking the valid record key for storing the values in the key. Array of 20. This array of 20 you are using to store the valid record key values. Hash 20. This is the record for storing. This is the array storing to the table. Hash 20 represents the hash table. And INSAK for traverse purpose, for reading the values and all. We will see one by one. First we will ask the user type. Given a maximum array 20. So we will give, just now I have seen test case. He has given 10. So once he enters the 10, we will read that value in the t size. So scanf %d ampersand t size. In the memory, it allocates the memory for the t size 2 bytes, and whatever user entered, the size of the table will be stored there. So earlier I have taken 10, so t size will be the 10. So printf, enter the number of elements. So now you are asking user how many valid records are there with you. So we will say a number from 8. Earlier you have seen 8. So that 8 will be stored in the n. Now you are starting reading 8 records, key values. For that you are using for loop. For I is equal to 0, I is less than t size, I plus plus, hash I is equal to minus 1. So first I already told you, once you know the size of the hash table, you initialize all the table with minus 1. You have to initialize with the minus 1. You should not be empty. It should be minus 1. Why minus 1? When you are reading, if the key value is minus 1, it says that it is empty. If it is not minus 1, some value is there, it is already filled. So for identifying for that purpose, we are initializing the t hash table with minus 1. That's why for I is equal to 0, I is less than t size, I plus plus, hash of I is equal to minus 1. So that I is equal to 0, I is less than t size. For example, in test case you have 10, so I is less than 10, I plus plus, hash I of is equal to minus 1. So it traverses each and every field of the array table, hash table. I is equal to 0, hash of 0 will be filled with minus 1, hash of 1, hash of 2, hash of 3. So hash table values will be filled with minus 1 from 0 to 9, 0 to t size minus 1, or if you assume 10, 0 to 9, all will be filled with -1. So now our task is completed. First step, we filled with -1 for identifying whether it is empty or not. The next, you are asking user to enter 8 numbers because he wants to store 8 numbers, 8 valid records. Now you are asking the user to enter 8 records. Step is you filled. Now the second step is this. So this is the second step. So you are asking user to enter the elements. For I is equal to 0, I is less than n. So because we stored, we asked the user here enter how many number elements, how many records you are going to. He entered n. In test case we have taken 8, so that's why n is equal to 8. So till I is less than n, I plus plus, you are reading scan of percentage d ampersand array of I. So in the array of 8, we are storing array of 0, array of 1, array of 2, array of 3, the values entered by the valid record key values entered by the user, you are storing in the array. So now we have ready with 8 records to be inserted into the hash table. Hash table size is 10. All hash tables records fields we filled with -1 for identifying whether it is empty or not. So now we are going to insert one by one into the hash table. What are the elements? 8 elements we read from the user. 8 elements. What are the 8 elements? Just see these 8 elements. So user entered these 8 elements 23, 43, 56, 668. So we are assuming. So this now you are entering all these 8 records into the hash table. So first we have ready with these 2. So now start reading. For I is equal to 0, I is less than t size, I plus plus. Now we have taken a hash table. Hash I is equal to -1. That value inside this loop we initialized. And for k is equal to 0, k is less than n, k plus plus. Now we have taken one more variable k for traversing the array. Where our valid records keys are stored. And array of k, first one k is equal to 0. Array of 0 we will assign to the key. So now we have taken that array of 0 value and we are assigning to key. That is valid record key, first valid record key. And that key are passing through the hash t function. That key will go to the hash t function. Hash t function returns what? An integer t function. What hash t function will do? It will take the key. So what is the key? 23, first one. What is the hash table size? 10. So it will take 23 and 10. It calculates. This is the hash t function. So it calculates key mod t size. So 23 mod 10. So I will be 3. And this hash t function will return 3. Then it will go to in the hash index because it's the first one. For example, if it is already in the usage, so then there is no guarantee that it will be empty or so we have to check if it is already in the usage. But in our program, we just now initialize with -1. So in the first scenario, it will insert. If not, so how will it insert? So first we got here we got key is equal to array of 0, we assign to key, and that key we pass it to hash t function. We pass to hash t function. So that it returns I value. Now we'll check. In the while condition, we'll check whether hash of I is not equals to minus 1. We are checking whether it is minus 1 or not minus 1. For example, if hash of I, we got 23 mod 10, we got 3. If hash of 3 is minus 1, then this while loop will not execute. The control comes to directly here. The control comes to directly here and it inside the value. It inserts the value. So before inserting loop, this while loop, we'll check the while loop. 2. If it is not minus 1 means the hash of the hash field not 1, then it is hash. Then rehash shell will be invoked. Then this function will be invoked. This rehash L I. So that 3 will be passed. So then 3 plus 1 it will take and it will calculate. Then I will be returned by that whatever the value returned in the rehash. H plus 1, H plus 2, H plus 3 it calculates. And that I value again it will check in the hash I till hash I is not equals to minus 1 it will do and then it will come out of the while loop. And then it will insert in the corresponding I value. H of 6 or H of 7, whichever it identifies the empty space. After coming out of the while loop, so it will come with a I value where the slot is empty. That the linear place. So here the for loop k is equal to 0, k is less than n, k plus plus. We'll take array of k, array of 0 will take first and we'll calculate key and we'll insert. And once the insertion is over, then it will go to the again for loop initialize increment decrement k plus plus. The control goes to the this for loop k for loop. Once first element is inserted, this will comes into the picture. This will come into the picture. Blue color. So the k will take increment and it tests the condition k is less than n or not. So the second one k becomes 1, it is less than 8. So again it will come to the inside the for loop array of 1. Whichever element is there in the array of 1 index that will be assigned to the key. Again it will calculate hash index for the second one and then it checks whether it is empty or not. If empty space identified immediately, it will assign that key value to the hash table corresponding index. So like that the linear probing program will calculates the hash value, hash index and checks whether it is empty or not by taking the minus 1 because we initialized initially with minus 1 all the records in the hash table. So that if it is minus 1, it is empty. If it is not minus 1, it is filled with some record. So that we'll rehash and again we'll find out the hash index and we'll check whether it is empty or not till you get. And once you get, it will come out of the corresponding hash I value. That is key is equal to hash. So in the corresponding table, okay. So then the I will be identified till the slot is empty. The corresponding I, it will come out of the while loop with that corresponding I where empty space identified. And then that key will be added. So this is the linear probing problem. After this, we will print the elements. After this, we will print the elements of what? Our hash table. What is the size of the hash table? 10. So T size is the hash table size. So now the elements in the hash table for I is equal to 0, I is less than T size. I plus plus. Printf element at the positions percentage d is equal to percentage d. So 0 percentage d will give the index value I 0, 1, 2, 3, 4, 5, 6, 7 up to 9. Zero to 9. And second generating the hash table index, and another one is generating the rehashing linear probing. Please execute. I think everybody has compiler with you. No, no, no quiz. Only this one is you execute this. You execute this program now. Note down patafat and execute. No quiz today. Do this program linear probing. Linear probing and quadratic probing. It is not there in the JNTU syllabus. But when you go to the interviews, they will ask you. But in the JNTU syllabus, they ask you theory. They will give some key values and they will ask you apply the linear probing and insert the values in the hash table. So then you have to explain theoretically. You have to explain theoretically how I explained earlier. Take a hash table, note down the index of the hash table, and then take each of the hash index of every and then insert. If already valid record is there, then go for linear probing h plus 1, h plus 2, h plus 3. Case of h plus 1, h plus 2, h plus 3 till you get the empty space and insert the record. Like that you have to answer in the theory. If they ask him, but they directly go in, how will you apply linear probing? When you apply linear probing, what is exactly linear probing? Have you heard the word linear probing? Have you heard the word quadratic probing? So then you have to tell yes, there are collision free techniques are there. In that open hashing is there, closed hashing is there. The open hashing is also known as called as or known as separate chaining, where arrays and linked list will be combined used, and closed hashing is there where the records will be inserted in the same hash table within the hash table only wherever the free slots are there. But in the open hashing, the records will be stored outside in the linked list. But that's why it is called as separate chaining. And in the closed hashing, within the hash table only will store the records, and this will be achieved by linear probing, quadratic probing, and random probing. In the linear probing, we'll use a formula hash function, but for converting the key into the index. The hash functions, how many hash functions are there? There are three hash functions. Hash functions can be, you can use a division method, that is a mod method, multiplication method, that is multiplying with a constant, or middle square method. Don't think that only these three. There is a lot of research is going on. When security is required, you can have your own hash function also. But whatever the hash function you are using for inserting, the same hash function you have to use for retrieving. You have to use the same hash function for retrieving. Whatever you hash function you can use for insertion, the same hash function you have to use for searching an element, or retrieving an element, or updating an element, or deleting an element. For example, in this case, you want to search 23. So then you have to apply the same hash function technique, 23 mod 10. In this scenario, we have taken table size, hash table size 10, and we want to insert 8 records. 23, all 8 records are there. In that, first one is 23. So inserted by using hash function 23 mod 10. For retrieving also, same hash function. So once is given whether 23 is there or not in the record, or you want to know the information about the key. For example, 23 is a vehicle number or ID number of employee. That employee information you want. So then for retrieving the 23 employee, 23 mod 10, same hash function you have to use. 23 mod 10, so we will get 3. So we will go to the hash 3. We will go to the hash 3, I is equal to 3. So in the hash 3, whatever the record is linked, that is the record of the this valid key 23. So that's why hash function, whichever you are using, whether division method or multiplication method or middle square method or your own hash function, the same hash function you have to use for retrieving, for searching, or for updating, for deleting. So execute this program. We'll give time. Take a global value t size. Take two functions. Two both returns integer value, and takes one argument, int hash t, and argument int k, hash index. By using a hash function, h of x is equal to key mod t size. And another function for linear probing, if not slot is empty, then rehash. This is linear probing function. Now see the main function. The main function, we are asking user what is the size of the hash table and how many elements you are going, how many records you are going to insert. That records we are keeping in, we are storing in one array called as array, and hash table name is hash. After taking the hash table size, t size, filled with. So now read the all 8 elements and store in the array. You can store like this, or otherwise parallelly read and convert and insert like that also you can do. That is based on your programming skills and understanding. If you understand well, directly you can read one by one and convert into hash index and then insert, and then ask the user to enter the second one, or otherwise ask user to enter 8 elements at a time and store in the array, and then read the array, take one by one and convert into the hash index. You can do like that. Note down. Please note down everybody. I will take attendance at 2:30. Please don't exit, all of you. Till I take, till I download the attendance, please don't exit. Do the exercise. So once you read all the elements, so now start inserting these elements into the hash table. So once you complete the accessing the valid records key, you can start inserting these valid records into the hash table. For k is equal to 0, k is less than n, k plus plus. So you are reading the array. Array size is n. You are reading array of 0, array of 1, array of 2, and you are assigning to the key one by one, and you are converting into the hash index, and then you are checking whether it is with -1 or any number, while hash of I is not equals to -1. If it is -1, then immediately it will skip the while loop and it will come to the hash of I, and then it assigns the key. If it is not -1 means some number is there, so that it will go to the rehashing, and then it identifies h of 1, h of 2 applies and gives you where empty space is. So if you execute this program 2-3 times, you can understand how these two functions are working, how linear probing is working. Anybody executed? Please don't quit till I download the attendance. Rohan, very nice. Sanjana, very nice. Good. The interview point of view, they will ask you the coding. Parallel, if you have Turbo C, or even you can take online compiler also. You can see this one, and once you are typing, you will get the concept how step by step is going on. The control flow, how it will go. The control goes from starting from main. First, it will take all the variables, arrays, declaration part. Then it will take this from the user size of the hash table. Then size of the n, number of elements to be inserted, valid record. Then it will initialize the hash table with -1. Then the control comes to reading the, accessing the valid records keys from the user, and it will store in the array. After storing, then it starts reading the array, each element, and converts into the hash index. This is the flow. After conversion, it will check in the hash table whether it is -1 or not. If it is -1, it is empty, so that it will assign that key to the hash table. If not, it will go for rehashing by invoking the rehash function, rehash hell function. Anybody done? Okay. Please do it at home, this one, this program. Okay, bye. Have a nice day, all of you. We are going on. Please do it at home, all of you. Thank you.